Hello, this will be a demonstration of proposition 14 from book 7 of Euclid's Elements, which says if there be as many numbers as we please, and another set of numbers equal in multitude, which taken 2 and 2 together are proportional, they will also be proportional ex aequali. Ex aequali, what that means is going to be carried over from book 5. And again, like the previous props, this has a counterpart in book 5 that is proposition 5.22, but because numbers are not magnitudes, we have to prove this again for numbers. We're given the simplest case with 3 numbers and another 3 numbers, such that the number a is to the number b, just as the number d is to the number e, and furthermore that the number b is to the number c, just as the number e is to the number f. And what we're going to prove is that ex aequali, going through the common terms, which are the number b and the number e, we will prove that the number a is to the number c, just as the number d is to the number f. Now, because the number a is to the number b, just as the number d is to the number e, this was given to us. Alternately, we can therefore say that the number a is to the number d, just as the number b is to the number e. This is by the previous proposition, 7.13, that if 4 numbers be proportional, they will also be proportional alternando. And so alternating one of the given proportions, we find the truth that the number a is to the number d, just as the number b is to the number e. And similarly, because the number b is to the number c, just as the number e is to the number f, this was given to us. It then follows, again by a proposition 7.13 alternando, that the number b is to the number e, just as the number c is to the number f. Now we have 2 ratios of numbers here, which are the same with the same ratio. So the number a is to the ratio a to d is the same as b to e, and the ratio c to f is also the same with b to e. Which means by a property of numbers, there is not an equivalent for 511 with number theory. It's just an obvious fact from the definition of proportionality that if 2 ratios are the same with the same ratio, they are the same with one another. So that because the 2 ratios a to d and c to f are the same with the same ratio, namely b to e, they are therefore the same with one another, so that the number a is to the number d, just as the number c is to the number f. And using proposition 7.13 for a final time, alternately, we can then say that the number a is to the number c, just as the number d is to the number f. And this is precisely what we set out to prove, which means we are done with the proposition, therefore, etc., q, e, d. Now, an example of this with numbers would be that 6 is to 9, just as 8 is to 12. And furthermore, that 9 is to 15, just as 12 is to 20, which means ex aequali, going through the equal terms, which here are 9 and 12, we can thus say that the number 6 is to the number 15, just as the number 8 is to the number 20. And this is obviously the case. This is a ratio of 2 to 5, and so is this. These are both ratios of 2 to 5, so yeah, they're the same ratio, which means this proposition holds. That's all I've got to say about this proposition, so I'll end the video here and move on to proposition 7.15.